Example 19. A hexagonal pyramid of side 30 mm and axis 60 mm long is resting on one of its triangular faces on HP such that its axis is parallel to VP. It is cut by a plane inclined at 30 degree to VP and 15 mm away from apex. Draw the projections of the remaining pyramid. So here this is a very interesting question. The hexagonal pyramid is given with side 30 mm and axis side 60 mm, and it is mentioned that this pyramid is resting with its triangular face on HP and the axis is parallel to VP, and then it is cut by an inclined section plane at 30 degree with respect to VP and 15 mm away from the apex. So we have to take an inclination angle with respect to VP, and we have to place the section plane 15 mm away from the apex. So we will see now how to imagine this first. So on your screen, hexagonal pyramid directly resting with its base on HV. Top view is a hexagon, as you can see. You have to draw this first while drawing, and this is the triangles which will appear in the front view. This is very important. You have to first assume that it is directly standing on HP, and you have to draw this front view and top view as hexagon. Then you have to make the inclination angle. So we will imagine that how to make the face rest on the HP as it is given in the question. The face is resting on the HP. So I will tilt this pyramid in such a way that now you see that I have made the pyramid horizontal. That means the face is more towards the HP. So this is, so we'll see now. You can observe some gap here. So I'll, now that I have placed the face on the HP. So this is going to be your top view, three triangles, and as you, this is going to be your front view, two triangles, but they should be laid on the HP. They should be lying on the HP. This is going to be our top view. You can see a contracted hexagon on the left side, and the section plane is given inclined to VP. So we will take first a parallel cutting plane, as you can see here this, and now I am tilting it. As this is a top view, you are seeing this as a line, the section plane as a line, and you can see the now the section plane cutting the pyramid at some angle, and this is going to be your front view. As you can see, I am toggling with it now. So this is going to be your final top view. Without planes, it will look something like this, and this is going to be its top view, and this is going to be its final front view. As you can see, the, so this is our final front view and top view, and I have darkened the portion which has been sectioned. And now for drawing the auxiliary view, you observe that I have taken one plane which is parallel to the section section plane, as you can see above, and I will project lines from each and every edge which has been cut by the section plane to get the true shape, which is actually similar to the sectional front view. The section portion of the front view, this is, this and this are same, but this is drawn with true lens, which we will see while drawing.
So first we will draw the projections of this hexagonal pyramid. Then after we will think of the true shape and auxiliary shape. So this is 30 mm distance, and as per the question, we will first draw the projections. So this is 30. So this completes our hexagon. I'll name this as 1, 2, 3, 4, 5, 6. This is your reference plane XY. As this is a pyramid, the front view will be a triangular portion. This is 1 dash and 6 dash. This is 2 dash and 5 dash, and also center is passing through this line. This is 3 dash and 4 dash, and the axis height is given as 60 mm. So here I mark the 60 mm, right? Say this is O dash. So this is not the actual projections. We have just assumed that as we have seen in the projection of solids. Now we have to tilt this object or pyramid. So I am extending this XY line, and I hope you remember the procedure for this. So I'm taking one point here. Say this is 3 dash 4 dash, because this point is this, and we'll take this distance till O. So this is your O dash, and from O dash this is going to be 1 dash, which will be obtained from this. Sorry, there's a slight mistake. Just and we'll mark the center also. Center line. This is the center line. This is the center line of this hexagon, and this O is meeting here, so we can name this as O. And 3 dash is coming from this point, and 3 is coming here. 4, 5, 6, 6 dash and 1 dash. This is 2 dash and 5 dash. So if we join all this portion, till this point, we have drawn the projections of this solid only. Dotted lines, because this edge is not visible on the top view. So section plane is 25 mm, 15 mm away from the apex. So I am marking 15 mm point here, and I will draw a vertical line straight downwards. See that I am not taking directly 15 mm here, because 15 mm is from the apex. So your 15 mm would be this line 15 mm, and this vertical mm, and the angle is given at 30 degree. So with this point I am marking the 30 degree angle here, and now this is going to be our section plane. This is the section plane, say x, and this portion has been removed. to get the sectional front view, we need to project lines from the section view where it is the, see there, this is the base of our hexagonal pyramid. So there are 2 points which has been cut off the base. This is the first point. So this is going to be your point A, and this is the second point. Say this is the point B. So the base has been cut here and here. So I have taken these 2 points here, and this is also cutting the general. So you will get one more point here. Similarly, we will get more 3 points starting from here. Like we will see, we will take this corner. So this is the 5th point, and this is the 5th line. So you will get 1 point here, and the 6th corner or 6th edge is coming from this side, and it is being cut here. So our 6th point will come here. So I'll name this AB, this is C, this is D, and so this is the 1, 2. So the 4th line is also being cut here. So we have to take the 4th line also. It will come here. Say this is E. So we will get this generator, this point here, not here. So this is A, B, C, D, E, say F and G. No, this is not the point here. Now I will so this is the portion which will be sectioned here. So again I am taking 45-degree angle and I am sectioning this portion. If this portion has been removed, we have to darken the remaining portion, which I will do now. So this portion will be visible, and this portion. We have to get the auxiliary view. So to get the auxiliary view, we will draw a line parallel to the cutting plane, which will be our auxiliary plane. Say this is x1, y1, and we will project lines from wherever the section plane is cutting this figure to the edges or the corners of this hexagonal pyramid. So I have taken all the points. I think I have taken this twice. So this is coming from this first line, and we have taken, this is the point A, So point A is at a distance of this much from the xy plane. This is our xy plane. So in our I need to project this lines beyond the auxiliary plane. So this is point A. Here this is point A. So the point B we have obtained from this line here. So this is point B, and this point here is lying on the line itself. So you'll get point here itself, and E point also will lie auxiliary view which has been formed here. We have to do hatching for this portion also. First I will write the numbers for this point A, B. This is B and this is G. This is D, C, E, F, so that it will be easy for you to copy afterwards. Now I will draw the hatching lines.
So this is the final solution of example 19. As you can see on your screen, this is our assumption that hexagonal pyramid is directly standing with its base on HP. The front view is a triangle and top view will be hexagon. And we have made this base edge, this triangular face here, as you can see in the dotted lines. We have tilted this so that the triangular face rests on the HP, as you can see here. So this was the front view and top view, and we have placed the section plane in such a way that it is making an angle 30 degree with respect to VP, and also 15 mm away from the apex. From here it is 15 mm. So this is your true shape.